So next, we're going to pivot to algorithms, the complex models, the billions of parameters that help us turn data into decisions. Please welcome Johannes Gerke. He's the director of Microsoft Research in Redmond. Johannes, welcome to Future Compute. I didn't give you much of an introduction. Perhaps you'd like to tell us a bit more about your work.
Sure. So I'm the lab director of Microsoft Research at Redmond. This is one of the largest research labs at Microsoft. And I also have a dual role in product. So I'm actually the head of AI of the Microsoft Teams backend. And before that, I spent about a decade, close to a decade, in Microsoft products. And so this dual role sort of, in some sense, keeps me honest, right? It sort of means that actually on the AI side, on the team side, I actually have to deliver products and services and really make our customers successful in the short term, right? In the sort of next quarter, as well as next year, next couple of years. As well as on the Microsoft Research side, actually, I have the privilege of dreaming about the future, right? Imagining what is the ambition that could change the world and could change our industry, and really plan long term ahead and think about sort of those, those trends that actually will be true in 5 to 10 years, and then we can work backwards to invent the next wave of technologies.
Yeah, absolutely. And folks, we will have time to get to your questions. If you want to just raise a hand, they'll bring a microphone to you, and the same thing, folks online. So let's talk about some of these projects. I think one in particular you mentioned backstage, AI at Scale, which is different from Scale AI, which just left the stage. Perhaps you would introduce us to this.
Right. I mean, so one of the capabilities that we see is that as we scale up models, as we scale up AI models, that the capabilities of these models are just becoming really groundbreaking. So for example, as we scale up models and we scale up natural language models, and we scale up multimodal models, we scale up graph neural networks, we scale up models that can actually approximate differential equations for molecular simulations, we see that as the models become larger, they don't only become better, but they also have different capabilities that we can use these models and afterwards adapt them to real-life situations with zero-shot or few-shot learning very quickly. Let me give an example of that. So we've trained one of the largest natural language models, GPT-3, of course, jointly with OpenAI. But now we've actually used this model to actually work on computer code. So this is very interesting. So if you think about computer code, right, I can now actually go ahead and write a comment, and then the model actually auto-completes afterwards directly the code that's being written. And so in a way, what we're doing is now, with AI, we're not only changing individual processes, but we're actually changing the overall workflow and making it really stepwise better. So what we're doing here in the future of programming, that's how I think about it, really, the future of software development, because it goes all the way about how large models are being actually used in code, all the way then down to actually how developers interact with these large models. What we're doing is not only we're taking software or models and directly using them then, but we're taking these models and then actually seeing what is the output of them. How can I actually make developers more productive with them? So in a way, we're really having this human-centered view of AI. So if I think about software now, it's not only I'm going to write code, comments, and directly then code is being written. But you can think about this actually now changes how software is being designed. So actually, what is software? I mean, why did I get excited about software? When I was a kid, there was this Commodore 64. Does actually anybody know here still Commodore 64? Okay, yeah, some hands go up. And so, this was this universal machine where I could be super creative, right? I could think of anything and then actually really make the machine do it. And so I feel like software development is one of the most creative tasks that we have. But what is it really? It's really about taking what you have in your hand, this intention that you have, this thought, this creative process, this creative idea, and then formalizing it in a way that computers can understand it. And so in a way, when you write this comment and the model and auto-completes the code, we're doing a little bit of that. But really, what we're trying to do is we're trying to elicit from you, from your brain, sort of this creative process, this specification that you're thinking about. And so why just go from comment to code, right? We could imagine that now this code, actually, how do we know this is the correct code? Yeah. So maybe you should be able to give some examples, input-output examples, and we should see that this code actually satisfies those input-output examples. Maybe if the code is not correct, we should actually help you to repair this code. So we believe that this is not just, okay, let's make writing of the code, actually the typing of the semicolons and opening and closing brackets faster, but this is really going to be a very new type of software development that's really going to be a step function in terms of usage, in terms of love from developers, and really in terms of overall productivity. So, and we actually see really good uptake. So I think the latest numbers are that about half the people who try Copilot, they stick with it. And then about 30% of the code that's actually been written by Copilot users is actually written by the model. So these are actually pretty amazing numbers. And as was said in the previous talk, this is just the beginning, right? When you have any model in production, you learn from the usage, you try to make it better, you improve it. And so we're just starting that virtuous cycle to hopefully make this really the future of software.
Something that's really interesting about Johannes when we spoke the first time, he was going across all the very, very different things he's working across at the same time. Everything from blurring the background for Microsoft Teams and other things like this to farming. So we have a lot of ground to cover. Let's see, I see a number of questions in the audience, so you have a microphone if you...
So my name is Rajaram, I'm from Infosys. See, if you look at enterprises, right, they have a lot of legacy technologies, right? And when you look at AML, typically all the use cases talk about, let's get some good data, apply these machine learning models, get these outcomes, and it's always seen as a separate thing, right? But if you see a landscape of an enterprise, there are a lot of these existing applications. What is the best architecture to infuse machine learning into applications? So assume they obviously have a lot of data. Can these applications become easily more intelligent so that they can give use cases out instead of taking the data, putting it somewhere and applying machine learning, right? Because I've seen I think more than maybe 6-7 years ago, I heard about the intelligence, right? Microsoft used to talk about how do you infuse intelligence into applications. I just wanted to check from your research, what is the best architecture to do that?
Yeah. So this is a great question. I would say there's not one size fits all because it depends on whether you're doing it on the server side, whether you're doing it on the client side, whether you're doing some combination of the two. So let me tell you one story, and I'm coming back to this noise suppression in Teams. I don't know whether anybody's using Teams noise suppression. I believe we have the industry-leading, the best noise suppression actually that we have. And this is actually a really cool story because it started out, and I'll come back to your question. Let me just take this little detour. Because it started out by us sitting in a meeting room in Redmond, talking to our colleagues in Europe, and we're just having lunch. And the lunch comes in a lunchbox, like a little bit what we had today. But in these lunchboxes, there are always these really delicious chips, and the first thing you do is you take the chips bag and you open it up and you start eating the chips. And then you hear all your colleagues in Europe complaining about, you can't hear anything, everybody's crumbling with these chips. And then somebody was joking, well, shouldn't you be able to do that, take that away with AI? And so we actually started looking at the noise suppression that we had. And the noise suppression that we had in Teams, there was actually noise suppression there, but it's for sort of stationary background noise, right? Assume you're in a coffee shop and you sort of dial the background noise down. Or assume you have a fan running, and then it dials the background noise down. And so we actually looked at and saw, well, how can we revolutionize a lot of these old-style control theory algorithms that we actually had in the media plane with machine learning? And the first one that we started out was, we actually looked at what our customers want and, where we actually have the biggest bang for the buck. And we actually then looked at noise suppression. And noise suppression was, again, one of those traditional control theory algorithms, Gaussian filter. And we actually developed, we looked at the literature, implemented 5 of these noise suppression algorithms, and as you imagine, they didn't really work so well in practice. And the reason of that is, of course, with us now being at home, we have very different types of noises, right? We have toilets flushing, we have babies crying, we have lawnmowers, leaf blowers, right? We have people coughing in the background. For me, we have a little dog, and the dog has been trained that when the dog goes to the door and scratches the door and barks, I have to let her out of the room. And if she's outside of the room and wants to come in, then she barks and I have to let her in. And so all these different interruptions. And so first of all, what we need to do is we need to create a very different training set and test set to actually then train the noise suppressor, and of course a deep learning-based noise suppressor, that actually then covers all the noise types that we actually see in practice. In addition, that comes now back to your question. The second thing we have to find is, what is the agility that we can get to actually deploy this model in practice? Do we deploy it on the server side? Do we deploy it on the client side? We just decided to do it on the client side because it's directly running, and then we get clean audio to the mixer in the cloud. But therefore, to come back to your question, my answer would be you should actually look at where you have the most agility. So find some easy where you can quickly iterate over the model, because the first model that you're going to deploy is not going to be perfect. And if it takes you half a year from the first model and half a year to the second model, you're very quickly seeing that you're not getting the ROI in your development process that you actually want. So look for something where you have agility. And we actually had to build a bunch of stuff. We had to build something where you can upload actually models in the client. You can do A/B testing in the client, right? Get the right kind of data back from the client, the right kind of telemetry, right? We use the Onyx runtime that you can also use in Microsoft Azure, and that's there on client runtimes to do all of this. So there's really great tooling available, but especially, and Teams was sort of a little bit of a legacy infrastructure. We had some modern infrastructure in Azure, but there were still some client pieces that were a little bit legacy infrastructure. And so what we looked for was especially that place where you really have agility, so you can iterate fast and you really see some ROI. And you also get feedback fast, because otherwise you don't know whether they're actually hitting the mark.
And just to go back to it, because I raised farming, do you want to explain what you're doing with FarmBeats?
Yeah, so this is just, I mean, Microsoft Research just, you know, I mean, I've been there now for 2 years, I'm still amazed. So this is a project that somebody started at Microsoft Research, right? In Microsoft Research, our goal is really to preserve the future for Microsoft and society. So our researchers are there, they have the freedom to explore what they want to do. Mm-hmm. On the other hand, you know, we're also part of a big company, right? So therefore, our goal is, of course, in the end, you know, to think about how we're actually going to create impact and what is that ambition that's going to change the world. And so one of our researchers, he thought, well, the world has a food problem, right? And food, you know, we don't not only need more food, but we need also nutritious food. So at the core of that, again, is another human. If I think about the idea of human-centric AI, the human is the farmer. How can we make the farmer more productive with data-driven agriculture, with precision agriculture? And so, again, if you think about food and climate change, right, climate change is impacting, of course, agriculture, but agriculture is also being impacted by climate change. But it could also be a solution to climate change, right, if you do sustainable farming. And so what he then looked at was, well, how can we actually give a farmer a 360-degree view of the actual farm? Mm-hmm. And so therefore what he did is then we said, well, we can deploy small-scale sensors on the farm. Well, you know, this would be a research project, would say, well, we're done. But actually in practice, there are lots of interesting problems. Where do you deploy these sensors? How many of these sensors do you deploy? How do you actually connect these sensors and then take them and get the data actually to the farm? Oh, and by the way, the farmhouse doesn't really have good connectivity. So, you know, how do you actually get the data from the farmhouse then actually into the cloud where you can do all of this great AI on it? And by the way, we don't only have data from these sensors, because these sensors are also pretty big and, you know, can have a few across, like, you know, acres and acres of land. So can we take this data and augment it with other data? For example, drones that are flying over the farm, or satellite data. Exactly. And how can we combine this data and make even more out of it? Mm-hmm. So again, this is an example where you have a lot of agility once the data is there. And you can now build these decision support systems for farmers to really understand how to make decisions across the farm. And, you know, I didn't know much about farming, but it's really, you know, things change so quickly. If you look at, for example, parts of Washington, right, 2021 was one of the driest months, or driest summers. Whereas then, if you look at 2020, it was one of the wettest, you know, seasons. So actually farmers there to make such sophisticated decisions about their soil, how much to water, how much to fertilize. And I always thought that farming was like above the ground, but there's actually so much more happening below the ground, which is really interesting. Yeah. So again, this is an example where we took a Microsoft Research project and then transitioned it into Azure, and it's actually now available in Azure, you know, through, and, you know, anybody here can go and actually use this as a solution.
A real problem and a fascinating problem, honestly. The time I've gotten to spend with CTOs on farms, looking at how they're trying to draw from all these different, from the sky, from underground, from, you know, machine vision, but cameras don't love mud and water and sun and holes and all these other things. It's a fascinating environment to think about. But I wanted to ask you, okay, so we were talking about farming, noise suppression, something else I know we're not going to get into, but differential privacy is something you've worked on that I find really interesting. What's the hardest thing you've worked on?
I mean, I think so there are different levels of hardness, right? So I've worked in product, and in product, the hard thing is always finding the easiest and fastest solution for the problem at hand, right? So again, I used to be a professor, and as a professor, you find a hard problem, you say, wow, this is really great. We can write lots of papers about it, right? And students can get their PhDs, and, you know, we can maybe do some really interesting deep science about it. If you're in a product, right, you see a hard problem, you think, wow, that's actually really bad. You know, we don't like hard problems. So what we can do is, what is actually a good, simple, and scalable solution that you can find to these problems? So especially in AI, you know, the issues are about availability of data. It's about the inner and outer loop and the speed of this inner and outer loop. Mm-hmm. It's trying to find, you know, things that are not replacing humans, that are not in a way just making the system process better, but really changing the way actually processes are. A good example of that is maybe AI in healthcare, and I'm sure there are many people here who may be in the space who are doing really amazing things. I mean, you know, we have a recent partnership, you know, with Nuance, of course, and they're doing really amazing things. For example, you can have now a conversation between a doctor and a patient And it's not only that this conversation then is transcribed, but actually the conversation is used to fill out a complete medical record.
Right.
That medical record is then annotated with the corresponding procedures and the procedure codes that are actually there. Mm-hmm. And then actually you can use that data then, of course, to give even the doctor more information about drug interaction or other, precision medicine that you otherwise not have. So just the idea of basically taking all of this data, bringing it into the fly loop, and then iterating over it can create so much value.
For sure. I saw a lot of hands up there. If we can get a microphone. Oh, no, you have it already. Great.
Hi, this is Victor Daniel Casas from JP Morgan. So you were telling me that you plan into the future when you think of AI products, right? So let's take the example of Codex. Codex was only possible because GPT was possible, GPT-2, GPT, and attention is all you need. It was a breakthrough in the AI community. So how can you foresee that a breakthrough will happen in order for you to plan a product like that? Mm-hmm. I'm just learning how to plan in AI, so definitely I will love your expertise. Thank you.
Right. I mean, so this is a great question. So let me give you maybe two examples. Right? One example, you can say there are some trends in society that will be inevitably true. For example, you could say society is aging. We're going to have a much broader spectrum of neurological diseases maybe that are going to be prevalent in society. So what are we going to do now about this so that we can address it in 10 or 20 years when it's even much more prevalent? You can say in the AI case, you can say, well, these large models like GPT-3, right, 175 billion parameters, I'll never be able to afford even an inference on this model, as compared to training it, right? Are we actually with larger models just going to overheat the planet, and are we going to create minimal value out of those? So the bet that you could make is that, well, there are a lot of really smart people working on making training better, making inference better, on creating the right kind of infrastructure, both from the hardware side, the software side, the usability side, of making these models actually affordable. So let's assume I would have these amazing capabilities. Let's assume there are other companies that are building it, such as Microsoft, that are building it. How could I create value for my customers by either taking existing workflows and, of course, automating some steps, or even rethinking complete workflows with AI in the loop? So in some sense, you're now making some bets on the future, namely, for example, that large models become really a platform, that I can large models, and with little extra training data, I can fine-tune them to use them for my task. That these large models actually will become affordable, that I can use them, and that the right kind of infrastructure is going to exist in Azure, that I can use it. So in some sense, you're making some of these bets, and you're sort of jumping along the ride on this rocket ship that we're all in right now with AI, where really human ingenuity is helping us to recreate capabilities that I never thought of as a human we could do. And so I believe there's actually a lot of really interesting things to come. And maybe give you one last example, right? I mean, we have this curiosity-driven lab. And therefore, our researchers, they don't only look at applications, but they look also at deep theory. Mm-hmm. And so we're beginning to understand a little bit more about the theory of deep learning as well. For example, there's now work that can take small models and take that parameterization and scale it up to larger models, and therefore, the fine-tuning of large models then is by an order of magnitude cheaper. And so this is just one of an example where actually there's deep theory that people do out of curiosity-driven research and then actually apply it and bring it back into the lab and then actually into the real world, into Azure, where you can all use it.
Now, online, someone in the audience wants to know if you're looking at climate change and also if you're marrying any of that work with the modeling you're doing in agriculture.
Right. So this is a great example. I mean, we at Microsoft actually have some really big sustainability goals, right? Are we going to be, zero waste, carbon negative, and water positive? So these are some really big goals here. And so one of the first things in order to understand problems such as sustainability and climate is first to even understand where the problem is. So what we're doing at Microsoft and Microsoft Research together, we're building what's called the planetary computer. Mm-hmm. And think of this as a data set that actually tells us about the climate and about our planet. So this is going to be, this part of that's already available, but this is going to be a huge data set of imagery and high scale and low scale resolution data all across the world, with the idea to even understand and measure what's going on. Similarly, in our work on sustainability, again, one of the first questions that we're asking is, where is actually, where are emissions being generated? Where in our, overall, what we're, all of our process, where are we not really sustainable? And so the first thing I would say we should always look at is measure, because then you know which problem you're actually going to attack.
I think we can grab one more question from the audience.
Can you talk a little bit about what Microsoft is doing with ethical AI, implementing it both for yourselves and for your Azure customers?
Yeah. So that's a really great question. And I mean, let me say it this way. I've been, I joined Microsoft, and there have been two things that I've been really impressed by. The first one is that how we handle customer data. So, I joined, and I was working for a long time in Office and E&D and, in Teams. And there's no way I could even look at a single piece of customer data. So there are processes in between and procedures that allow us. I cannot log into the machine. So customer data is really treated with the utmost respect. Second of all, I've been really impressed by sort of our process internally of how we look at bias and fairness and responsible AI in general. So we have a council called the Ether Council that directly actually advises the senior leadership team at Microsoft, that looks at all processes internally. So whenever you train a model, is your training data set actually biased? What are the right kind of tools in terms of fair learning and others that we actually also have open source for anybody in Azure to use? So within Microsoft, there is a lot of set of great processes and reviews that you should go through before you actually release a customer-facing model. In addition, we actually make these tools all available in Azure ML for the use of all of our customers. I mean, I can maybe say one other cool thing, right? So coming back to Teams, actually. So meetings are actually a reflection of a company's culture, right? And we've always looked at, well, how can we make the real-time interaction better, right? How can we make sure that there's no noise, that you can see me really well and all the wrinkles on my face, right? Or, how you can hear me really well. But if meetings are also a reflection of a company culture, shouldn't we look at that actually can create technologies such that meetings by themselves are effective and inclusive? Maybe I interrupt people all the time. Maybe I should therefore be known that actually I'm interrupting somebody. So we've actually done studies, and we've published some studies also jointly with Microsoft Research to look at actually what would it make to make a meeting effective. Does, for example, an inclusive, does having video on, does it make the meeting more inclusive or not? Because maybe I can now actually, I see a little bit in the back here, but I cannot really see a facial expression. But if you had video on in a meeting, maybe I could see this, and that would make the meeting actually more inclusive. So we're looking together and see also how can we use technology not only sort of to make the actual physical meeting experience as good as possible and, of course, create new experiences there, but also how do we, use technology to influence the culture overall.
I'm not sure if we mentioned that you come to this from academia, that you spent a long time as a professor. I'm curious how this has been to switch gears, but also what the collaboration would look like between research and product for you now.
Right. I mean, Microsoft Research is now in its 4th decade, and it was set up really to, again, preserve the future of Microsoft and society. And there's been a huge history of very long, research transfer or product impact from Microsoft Research. And if I look at, in my own area, again, data and AI, self-tuning database systems, right? Came out the Auto Admin project with Microsoft Research, which was actually about, you have all these hundreds of knobs in database systems. I don't know if anybody here used database systems or has dealt with them. And they have like hundreds and hundreds of knobs. How do you use machine learning, for example, to set these knobs and to help database administrators to be much more effective and getting the last performance out of database systems? And there's been a long set of technology transfers around graphics, operating systems, and of course now machine learning. And so what we do is our researchers, they have the ability and the flexibility to do curiosity-driven research, but then often they also get together and work in larger projects and sometimes even mission-driven research, where they have together a mission, they are all in and try to change the world with that mission. And so, we know what product groups want, product groups know what we have, and there's a lot of interaction across both directions.
Interesting. I asked you what was hardest, what was your greatest challenge. Has anything surprised you recently?
I think what's really surprised me is the speed at which technology progresses, especially the machine learning rate right now. I mean, I would have never thought that we have the capabilities with the large models that we have right now. I mean, a lot of the capabilities that we have now where we can take tasks that a human would take several seconds to complete can now be done with compute, right? And if you now take this exponential trend and extrapolate out into the future, right? This means that actually a lot of tasks that we could have done as humans could now be done with AI. And so therefore, the way I think we have to think about this as researchers and in the technology scene is we have to think about how do we actually take AI and augment and make humans even more productive. So I always think about the human in the center and how can I take human capabilities and augment them with AI. And I think that's sort of the kind of products and services that I like to build.
See, I somehow didn't expect you to be surprised by speed in technology. You stumped a little bit. I was waiting for you to say, no, this is other things. We do farming, we do this, when there's like something else that we've not heard of. But
No, and I think you can see that one of the applications, for example, is in molecular simulations. Right. So again, this is about new materials design. Can we actually build a hydrogen battery and so on?
Yeah.
And these simulations used to be done in the lab, and we can now move them from lab into silicon.
Yeah.
So what this means is we can actually now take simulations that were usually done, for example, by Navier-Stokes equations, or by very sophisticated differential equations. We can now approximate them with deep learning.
Yeah.
And again, you get not only a factor of 2 speed improvement, you get orders of magnitude speed improvement. And so just seeing the speed of advancement here across the machine learning just really had over the last decade, took me a little bit by surprise. I mean, my thesis in the late 90s was about decision trees and scalable decision tree construction. And if you look at the capabilities that we have now, I still find them quite stunning, and I can't wait to see what we're actually going to have in the next decade.
That's a lovely note to end on. We are out of time. Thank you so much.
Thank you, Jennifer.
That's great.